Okay, so there's 3 pyramids in Giza, and one is 147, the biggest one is 147 meters tall, the next one is 142, and the third smaller one of 64 meters tall. It's asking, can the volumes of the 2 smaller pyramids fit inside the larger one? Okay, so we want to know the percentage volume of each of these. Okay, so we want the multiplier, so we know that the height, these are to do with heights, so those are lengths. So the ratio or the length multiplier, okay, of the second smallest to the biggest, if we work out that length multiplier, okay, it is about 96.6. Okay, so 0.966 times the length. Okay, now to figure out the volume multiplier, I'm going to cube that. So when I cube that, I'm going to end up with about 90.1. So 0.901 times volume. Okay, so that's the largest, comparing the middle one to the largest one. So I want to see if I can, that it occupies about 90% of the volume. I want to figure out what percentage volume that the smaller one takes up. So to do that, I need my length multiplier. So I'm going to do 64 divided by 147. And I'm going to work that out. So 64 divided by 147 is going to be about 43.5%. Okay, so 0.435. Okay, so this is times the length. Okay, since height is length. If I want to find out the volume multiplier, I'm going to take that and cube it. So I'm going to cube that number, and I'm going to end up with 0.0825. So I'm going to round that to point. That's going to be about 8.3%. Okay, this is times the volume. Well, if that's the case, then I know that 8% and 90% will fit inside 100%. So the volume of the 2 pyramids, the 2 smaller pyramids, can fit inside the larger one. The largest. Okay, moving on. Okay, so we have a spherical balloon. It increases by double the surface area. How does the volume increase? Well, I know how to go from area to volume. I know how to go from area to side length. How do I go from area to volume? Well, even though surface area is still, we're still talking about areas or squares. And we can go from area to volume by looking at, well, let's just scroll all the way back. I can go from area to volume by square rooting to get the length multiplier, and then I can cube to get the volume multiplier. Okay, so if I double the area, I can figure that increase, and I can figure that increase. So, going back to this original problem, I have a doubling of the surface area. So 2 times is my area. That means that square root 2 times is my length. Well, if I want to go from length to volume, I take that's about approximately 1.41 times the length I'm going to need. I'm going to have to increase the length of that, length, width, and height of that balloon by 1.41 times to get double the surface area. If I want to then convert that to volume, I take that square root 2 length and I'm going to cube it. And that's going to give me my volume, which is using my calculator here, I'm going to get about 2.83 times the volume. Okay, so if I increase the surface area by double, I'm going to increase the volume by about 2.83 times more volume. So there's my answer. And I can use I go from area to length, from length to volume. So this problem is fairly similar. Now we have a cube that has 3 times greater volume than cube B. Okay, so A is 3 times bigger. By what factor is the surface area greater in cube B than cube A? Actually, this should be different. So say cube A has a bigger surface area than cube B. Okay, so let's fix that first. Okay, well, still I need to figure out, well, if my multiplier is 3 times for volume, then I can cube root. Okay, so I'm going to just say 3 times volume works out to cube root of 3 times length. Okay, which is approximately, my handy calculator here, okay, about 1.44 times the length. Okay. Now I don't want the length, I want the surface area. So how do I go from 1.44 times length to surface area, or area? So I take my 1.44 times and I square it to get area. And when I do that, I get approximately 2.08, looks like it. Okay, so my surface area increases by 2.08 times the surface area. Okay, so if I triple the volume, my surface area increases by just a little bit more than double. So there it is. So the key is going to be, again, to go between areas, volumes, and length, we can use kind of this chart to help us map our way through. Okay, so this chart's very handy.